Hi, welcome to my video on find the concavity of each polynomial. Find the concavity. Notice here we have a cubic, which is degree 3, so y equals negative 1/3 x cubed plus 4x. Concavity is when we do the second derivative, making it equal to 0. So the first derivative, y prime, negative 1/3 times 3 is negative 1. And the 3, subtract 1 is a 2. And we have a linear, so the derivative of 4x is a 4. This is a 1 understood to be here, so 1 times 4 is 4. When you subtract 1 from 1, you get 0 next to the 0 is 1. So that's the first derivative, and we do the second derivative. And we take negative 1 multiplied by 2, which is negative 2, and decrease the exponent or power by 1. And the derivative of a constant is 0. So to find concavity, we let y prime equals 0. So that means we have negative 2x is equal to 0. Divide by negative 2, x is 0. So we take 0 and plug it back into the main equation, up to cubic, so it's a negative 1/3, 0 cubed plus 4 times 0. So 0 cubed is 0, negative 1/3 times 0 is 0, 4 times 0 is 0, so we have 0. So we have the concavity is at the inflection point is where the concavity starts. The inflection point is 0, 0. So what happens if we make y prime greater than 0, and that's when we have negative 2x is greater than 0, divide by negative 2, x is less than 0. Dividing by negative change the inequality around. And if we go y prime is less than 0, that means negative 2x is less than 0. Divide by negative 2, x becomes greater than 0. So what we have, if you think about it, look at it, we have the point of inflection 0, 0. So that means that the concavity is greater than 0. That means it's positive, so that means it's doing that. And when the concavity is negative, it's opening downwards, so it's doing that. So when x is less than 0, we have a positive concavity, so that means it goes down like that and up. And when we have concavity negative, which means it's opening downward, so that means when x is greater than 0, which is here, it will do this. So that's the concavity. I didn't show the x-intercepts and y-intercepts, etc., but we could find these values of x. We know that 0 is the x and y intercept, but we could find these by letting this equal to 0 and solving it. And we could do the first derivative to find that on the right side of 0, the slope is positive. On the left side of 0, this slope is negative. And this is the maximum point. The slope on this side is negative. Slope on this side is positive, so that's why there's a maximum. This is a minimum, because the slope of the curve here is positive. Slope of the curve here is negative, so that makes this a minimum point. But I just wanted to find the concavity without doing all the others, and slope of the curve, and x and y intercepts. Number 2, find the concavity of this. Now this is a quartic. Again, we do the derivative. So 4 times 1/12 is 1/3, and 4 take away, subtract 1, I say take away. That's what I'm used to saying. 9 over 2 times 2 is a 9. X, 2 becomes a 1. And the double derivative is the derivative of the derivative. 1/3 times 3 is 1, x squared. And the derivative of 9x is, negative 9x is negative 9. So, to get the concavity, the y prime has to be equal to 0. So that means that x squared minus 9 is equal to 0. So that means that x plus 3, x minus 3 is equal to 0. So right here, x is equal to negative 3. And right here, x is equal to 3 plus minus. So there are 2 points. So what we do, if we think about it, if you draw this is y double prime, and the y double prime is occurring at negative 3 and 3. That's where 0. So if what happens is if we take a 4 and we take a number in between 0, take another number to the left of that negative 4. So if you take a 4 and put a 4 in here, that becomes a plus. Put a 4 here, becomes a plus. So that's a plus and a plus, which gives us a positive. Put a 0 here, we get a plus. Put a 0 here, we get a minus. So plus and a minus product is a minus. Put a negative 4 here is negative. Negative 4 here is negative. And that's a negative times a negative is a positive. So that means that at 3, is a plus, so that means plus is opening, it's a positive, so it's opening like this. So at 3, the curve is doing this, positive. And at negative 3 is a positive, so it's also doing this, because it's concave upward. And in the middle, so this is going down like this, and this one is going down like this. So between negative 3 and 3 is negative, so it means it's doing this. So let's find these points on the graph where this is occurring. So let's take x equals 3, or let's do negative 3, and then we'll do a 3. So we'll take the 3, and we'll plug it into the x values here. So 1/12, and that's negative 3 to the 4th minus 9 over 2, negative 3 squared. So that's 1/12, and negative 3 to the 4th power is 81, and 9 over 2, negative 3 squared is a 9. So that gives us 81 over 12 minus 81 over 2. And so we can reduce this down if we want. We can divide by 3, so that gives us 27 over, divide by 3, 27 over 4 minus 81 over 2. 4 is a common denominator, so we get 27 over 4 minus, so 2 times 2 is 4, 81 times 2 is 162, so that gives us a negative 135 over 4, or we could also say that's a negative 33 3/4, or 0.75. So this point is negative 3, negative 33 3/4. So what about if we put 3 in here? So y equals 1/12, 3 to the 4th minus 9 over 2, 3 squared. So notice that 3 to the 4th is also 81, and 3 squared is also 9. So that means this is the same coming down through here. So this is going to end up to be the same answer as negative 33 3/4. So this point of concavity is x is 3. We get a negative 3 3/4. So if you have your graph, and I just do another approximation. So if you have 0, and you have a 3, and you have a negative 3, so that means that at the negative 3, at this point of, that's way down here, that's make sure that's a 3. This point is way down here, right there, and this point is right here, the same distance down. And so the curve is it's going down here and opening up. And over here it's doing the same thing because it's positive. It's doing this like this. And that means if you go back and look and see where the middle is, well, if you make x equals 0 here, you get y is 0. So the middle is, it's going to go like this. So this is the two inflection points right here. So this is 3, negative 33 3/4. And this one is negative 3, negative 33 3/4. So again, it's positive at this point here because it's making a bend, and here it's doing the same thing. And notice it's concave downward here and concave, and in between the two inflection points, it's opening down. So this is the plus, this is the plus, this is the minus. So positive, concave, opening up, positive, opening up, and a negative is opening down. So that's showing about the concavity. And again, if you did all the x-intercepts and y-intercepts and you did the first derivative in terms of slope of the tangents, you would see a much better picture. So that brings us to the end. Again, if you like my video, click the like button, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. The content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.